Lesson 1.6, we're going to be writing fractions in higher terms and in lower terms in this lesson. So when we are going to be dividing fractions into lowest terms, what we have to do is divide both the numerator and the denominator by the greatest common factor. But a lot of times it's not so simple to know the greatest common factor. So what you can do is just be prepared to divide more than once. I'm going to show an example here, 60 over 80. So I'm trying to think of two numbers that I can divide by. That's the biggest that comes to mind. And what pops into my mind for these is 10. So I'm going to divide both of these by 10. And let's see what happens. 60 divided by 10 is 6, and 80 divided by 10 is 8. But that's not in lowest terms yet, so I have to be prepared to divide again. So I'm going to divide by 2 and divide by 2. And that's going to give me a fraction 3 over 4, 3/4. The greatest common factor of 60 and 80 is 20, but that's not always going to pop in my mind. So as I said, if you divide once, twice, 3 times, 4 times, in the end it doesn't matter as long as you reach your goal of the fraction in lowest terms. So the method that I showed is the method that's most common, and that's dividing by the greatest common factor to write a fraction in lowest terms. So we saw in the example above that we did end up getting to 6/8, and that when we take 6/8 and we divide by the greatest common factor, which in this case is just a 2, we're going to have our simplest form, 3/4. It's equivalent to 6/8, but it's in lowest terms. For example 2, we're going to reduce 12/15 to its lowest terms. So we think about the common factor that is the biggest for both of these. It has to be the same. So just because you can divide a 12 by 4 and a 15 by 5 doesn't mean that you can do that. You have to pick the same factor. And the greatest common factor of these two numbers is a 3. So we're going to divide by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. And so our lowest terms is 4/5. This time we're going to be reducing an improper fraction to lowest terms. So you have a couple of choices. The first way is to reduce the fraction as it is, leave it improper, and start to divide. So you may start to divide here by 5, and let's see where we end up. 65 divided by 5 is 13, and 30 divided by 5 is 6. It did ask us to change it to a mixed number, so from here we're going to use our dividing up method. 6 goes into 13 2 times with 1 left over. So method 1 gives us an answer of 2 1/6, where we're reducing the improper fraction and then changing the improper fraction to a mixed number. Alternatively, what we could do is take 65/30 and change that to a mixed number first. So 30 goes into 65 2 times with 5 left over 30. And then from here we can reduce our proper fraction into lowest terms. The whole number doesn't change, but 5 divided by 5 is 1, and 30 divided by 5 is 6. So we end up with the same result either way. So it's going to be your decision, and you can go between the two methods depending on the numbers in front of you. Method 2, you can see my little emoji there. This is not a method that I recommend. I find it pretty labor intensive, so I'm only going to show one example, and it's a product of prime factors. So you're going to write all the prime factors, and then you're going to cancel the matching factors. So here we have 21 over 28. So what you're doing here is you're saying what makes 21? 3 times 7 makes 21 over what makes 28. So you're really doing a factor tree here. What makes 28? Well, 4 times 7, but I'm going to use prime factors. So 2 times 2 makes 4 times 7. You notice that all these numbers here are prime numbers. This is a product of prime factors. And then what you do is you cancel out the ones that match each other. So you'd actually cancel out the 7s. 7 divided by 7, they're gone, leaving us with a numerator of 3 and a denominator of 2 times 2, which is 4. Personally, I find this method to just be a little bit tedious. I'd much rather take 21 over 28 and divide quickly by 7, both the numerator and denominator, and I would end up with 3/4. There's some really helpful hints on page 41 for reducing fractions. If a number is even, you can divide by 2. So if the number ends in a 0, 2, 4, 6, or 8, that's an even number, you can divide by 2. So if you're at a loss and you don't know, but you have 2 even numbers, you can start with dividing them by 2. Remember, it doesn't matter how many times you divide, as long as you get down to lowest terms. The 3 is really cool. If a number is divisible by 3, it means that the digits added together are divisible by 3. So the example they give is the number 81. So you can ask yourself, is 81 divisible by 3? I don't know. So what I do is I add the digits. 8 plus 1 is 9. 9 is divisible by 3. So therefore 81 is divisible by 3. And this works for all sorts of numbers. Let's look at another one, 72. 7 plus 2 is 9. So because the numbers added together make a number that is divisible by 3, 72 is divisible by 3. One more example, 105. You add 1 plus 0 plus 5 is equal to 6. Well, 6 is divisible by 3, so 105 is also divisible by 3. So that's a super cool rule for 3s. If you want to know if a number is divided by 5, if it ends in a 0 or 5, then it's divisible by 5. And then the last one that we have for reducing fractions is if the number ends in a 0, you can divide it by 10. So we always want to work for lowest terms, even if it takes us more than one division. So we're going to take a look at the 1.6a do together. We're going to be reducing to lowest terms. The way you reduce and the way I reduce might be sometimes different. As long as we get to the same result, that's all that matters. So here I'm going to choose the same number to divide by. Both of these numbers are divisible by 12. So I'm going to get down to lowest terms right away. But if you divided by 2 or you divided by 4 or something else, you might just have to then keep going. 2/3 is your lowest terms there. For number 2 below, 42 over 8, remember you have a choice. It's asking to reduce to lowest terms. It's not asking for a mixed number, so I'm actually not going to change to a mixed number, although you could, and you could leave it like that or change it back. But lowest terms here is dividing by the same. I'm not sure, so I'm going to go ahead and divide them both by 2. And 42 divided by 2 is 21, and 8 divided by 2 is 4. So I check again. Do they have anything in common? They don't, so that is lowest terms. Number 3, I have 12/18. So I'm thinking, what's my biggest number they're both divisible by? My biggest number is a 6. But again, if you started with a 2, that just means you have to keep going. 12 divided by 6 is 2, and 18 divided by 6 is 3. And then number 4, we've got 40 over 16. Again, they're not asking for a mixed number, so I'm not going to go that route. I'm going to just start to divide them. The first thing that pops into my mind is a 4. I think I can do better than a 4, but I'm not sure. Let me think about something bigger. Can I make more than a 4? I can. I can divide these both by 8. But again, if you divide by 2, if you divide by 4, that's totally fine. You just keep going. 40 divided by 8 is 5, and 16 divided by 8 is 2. So lowest terms is 5 over 2. For equivalent fractions, these are fractions that are equal to one another but look different. What we've been doing up until now is making equivalent fractions. Reducing fractions to lowest terms is simply changing the numbers but not changing the actual value. So 1/2 in this picture is the same thing as 2/4, is the same thing as 4/8, as the same thing as 8/16. Now this guy in class feels like the 8/16 is kind of like more bang for your buck because the numbers are bigger, but really they're all the same. So we're going to raise fractions to a specific higher term. So if we want to do this, we have to use multiplication instead of division. So if we're going to express 2/3 is equal to something over 6, what we have to notice is that how did we get from 3 to 6? We multiplied by 2. And so because we did that in the denominator, we have to do the same thing in the numerator. And 2/3 and 4/6, they are equivalent. One is higher terms and one is lower terms. So for example, if we're going to raise the terms from 3/5 to something over 20, we have to notice how we move in our denominator. We multiply by 4 to get from 5 to 20, so we have to do the same in our numerator. So we're going to have 12 over 20. For our second example, how do we get from 5 to 15? We multiply by 3. And so in our numerator, we have to multiply by 3 as well. And so we're going to end up with 9/15. So we're going to be expressing these fractions, equivalent fractions in higher terms, using the denominators to guide us. So 5 up to 20 means we're multiplying by 4. So we're going to do the same here on our numerator. 4 times 4 is 16. For number 2, we're multiplying 9 to get to 54. We're multiplying by 6. And we're going to do the same in our numerator. So we're going to end up with 42. For number 3, we're going to be working a little bit backwards. We can also use division concept here. So we can be moving from 75 down to 15, or we can be looking at what times 15 makes 75. So we can look backwards or forwards. If we look backwards, it means I'm dividing by 5. If we look forwards, it means I'm multiplying by 5. So the division here can be helpful because now we're going to do the same in our numerator. 20 divided by 5 is 4, and we can check it the other way. 4 times 5 is 20, 15 times 5 is 75. So we're expressing our fractions in lower or higher terms using our denominator. So good luck with the exercises for 1.6.